Good morning, everyone, and welcome to today's webinar on using data science to decarbonize the built environment. My name is Taladea, and I'm the New Whole Building Coordinator at the PG&E Energy Centers, and I'll be your host for today. We have a great lineup of speakers today. I'm going to turn it over to David Lehrer from the Center for Built Environment to introduce himself and get us started.
Okay, thank you, Tala, and thank you for your support in putting this all together. I'm David Lehrer. I'm with the Center for the Built Environment, which is a building science research center at UC Berkeley. And we've been co-hosting these events with the PG&E Energy Center for many years now. A little background on today. We all know that climate change is one of our biggest challenges. However, we now have new tools, data sets, ways of dealing with this data, and many tools and products that are helping us to deal with this challenge and to understand what the issues are and to solve them. A positive note is, as we'll learn today, there's a lot of focus and investment in creating these new tools and systems to help us deal with this issue. And we'll hear from many experts today who are doing this work, this important work. The speakers will be talking about their work and also sharing information about new approaches, tools, and many data sources that are freely available for all of us to use. I want to thank the CBE industry partners. This is a consortium, a very diverse group of folks from the building industry and other industries. And by supporting and guiding our work, they help CBE to focus on highly relevant research topics. So I'm very excited to hear these speakers today. We'll hear first from Billie Faircloth, partner and research director with Kieran Timberlake. Next, we'll hear from Gabriela Volpato, and she has two roles as a product manager with WattTime. Today, she'll be focusing on her work as a data manager with Climate Trace. We'll also hear from Manos Saratsis. He's the co-founder and head of Product A. And then finally, we'll hear from Mark Siemers, the director of engineering with Measurable. Each speaker will have about 20 minutes. We'll have some Q&A after each speaker, time permitting, and then we'll wrap up with a panel of all the speakers. And just a quick note, I also want to acknowledge Swazit Kam. She's a friend and colleague, and during her time at Berkeley, she, as a graduate student at Berkeley, she proposed this as a topic. So I want to thank her for her idea and her involvement in the early planning of this event. So finally, logistics. During the seminar, you can use the chat, and we will keep track of your questions, and we'll either provide those for discussion at the end of each talk, or we'll hold those all for the end. And as Tala mentioned, there is an online feedback form, and we'll share the link again with you all at the end. So with that, I'm going to invite Billie to share her screen. And I believe I'll just click stop here.
All right, thank you, David. Hello, everyone. There we go.
There it is, great.
Yeah, excellent, okay. All right, well, hello, everyone, and thank you for having us and inviting us to join this talk on this important topic on decarbonizing with data. First thing that I want to just say is that I am not a data scientist. I am an architect, research director, and I represent architectural practice in Philadelphia, Kieran Timberlake. But we do come at data from a very particular perspective, mainly because of the work that we have done in our practice over many years and many decades has prioritized essentially an inquiry-based approach to design, which means that on a day-by-day basis, we're leveraging inquiry to develop actionable insight into design decision-making. On a month-by-month basis, we're proving new concepts that have the potential for practice transformation. Annually, we are developing new knowledge, peer-reviewed knowledge on the built environment through a series of studies, as well as developing platform by platform new workflows that elevate our profession. And underpinning all of this is data, as well as our embracing of a transdisciplinary mindset, or working across multiple disciplines to really examine themes of time scale, time scale of time, change over time, and adaptability over time, but also to explore through the lens of multiple disciplines the gaps that exist in our knowledge as we engage the built environment. Simultaneously, with our transdisciplinary mindset, as well as our as support from data, we are in our work always advocating for new system boundaries in order to demonstrate the potential for design interventions to basically address the things that often we cannot see in the built environment. All of this means that often in our work, we are challenging disciplinary data and modeling habits. And more often than not, and increasingly, and in particular with two projects that I'm going to show today, what we're doing is advocating for mosaicing of data in a way that allows us to see where these gaps are in our disciplinary habits and practices. The project that I want to talk about to demonstrate this question of how to decarbonize through data is a project that we began really with a back of the envelope calculation in 2008. And it's a project that is now known throughout the industry as TALLY. It is the first life cycle assessment application that lets us calculate the environmental impacts of our building material selections directly in a building information model. But it really is a modeling practice called life cycle assessment. And as a modeling method, what it does essentially is allows us to associate building information modeling inputs with other types of inputs, outputs, and to calculate the potential environmental impacts of a product system through its life cycle. So what this simply means is that given a building, in this case is boundary, we can basically look across various stages of that building, from its the manufacturing of the materials, including extraction and transport of materials that will ultimately go into that building. We can look at the construction, we can look at the use, we can look at the end of life. We can also look at things like reuse, recovery, and recycling, and along the way understand both the inputs of material, energy, and water, as well as emissions across a range of different categories. And of course, we can look at emissions associated with global warming potential, or what we've been talking about more recently as embodied carbon. So in this instance, our own modeling practice with embodied carbon started with this house in our pursuit of a more formalized way of understanding impact. Started with this house called the La Valley House, which is located on a sensitive site along Maryland's Chesapeake Bay. But the house was actually completed in 2007, but it made a bid to directly and proactively engage change over time. And more specifically, it was designed for disassembly. So in 2008, we wanted to really play out the scenario of design for disassembly. And we began to use the data that we could find at the time, which is likely data we wouldn't use now, but we began to use the data we could find at the time to really begin to calculate the value of recovered materials and to understand if there was a way to associate that value of recovered materials with an avoided burden of additional CO2 emissions. Over time, especially through 2011 and 2012, we began to develop this into a formal workflow and associate this directly with life cycle assessment modeling practices. And what we are able to do in a very direct way is now associate what is a rather complex modeling practice directly with design decision making. So that's really what TALLY is attempting to do. It's attempting to help designers associate data that reflects impacts, specifically ecological impacts of the environment, with modeled elements. And this practice has become known as BIM-LCA, which is a methodology that, again, connects these modeled elements to lifecycle inventory data, which does permit parameterization, optioning, and optimization of building materials and assemblies to minimize these ecological impacts. Now, of course, what we are doing right now with this type of modeling practice with BIM-LCA is we're asking a lot of questions about our design strategies and which strategies add up to lower impacts. But underlying all of this is a series of data. And these data are sourced primarily today from two places. So we can access data or databases of general data that represent impacts within the industry, but we can also access data through environmental product declarations. And this is essentially a manufacturer's report that's created according to what is known as a set of product category rules. So essentially, for a given product, a database or a manufacturer discloses the expected emissions across the product in life cycle stages. So many of you may have heard about environmental product declarations. Perhaps you're accessing databases of environmental product declarations. One thing that we have been tracking as developers of Tally and as early adopters of these types of data is really the current landscape in environmental product declarations and really trying to understand what the quality of the EPDs are. And we are right now in a place where not all EPDs are created equally, but we believe that we're going to get to higher quality EPDs in the future, given some of the commitments that have been made to increase the quality of these data. So what problems do you need to solve to run a life cycle assessment? So looking a little bit more deeply into life cycle assessment as a method, especially BIM LCA, essentially what we're able to do is to first solve the problem of quantity surveying, or what materials go into your building, and then associate those materials with life cycle inventory, or essentially answer the question through impact data: how are the building materials made? And that allows us to, again, associate the making of those materials with emissions. Now, in Tally, in particular, in any modeling practice, what we know is that not all our BIM models do not reflect reality. So what Tally is doing is it is addressing this by allowing designers to associate more detailed information through a series of prompts with their models to get at higher resolution models. And then what a designer could do is essentially study a series of choices that are made. So we could do, for instance, a study that looks at material comparisons. We can compare assemblies to each other. We can compare systems. We can look at whole buildings. And we're able to then ask very specific questions about choices, about different, say, assemblies or different material types, comparing those together. So a simple material comparison could look something like this, simply taking a series of different insulation types that all have, for instance, the same R value, and comparing those one to another to begin to understand the relative impacts across, say, global warming potential or embodied carbon, but also according to other types of impacts: acidification, eutrophication, smog formation, etc. What's interesting, of course, is that we can then nest this kind of comparison in another comparison. So, for instance, this is an assessment that we did that looks at a series of unitized envelope assemblies. Actually, we were looking at stick-built versus fully unitized assemblies, and we were trying to understand the sort of relative embodied environment impacts of both of these options. And as we looked at this assessment, we were able to see, whoa, the insulation contributes greatly. So given the data that we had previously, building that into this assessment, we're able to then start to optimize an option with different insulation types to get at an assembly that has a lower embodied carbon impact. And we're also able to engage more complex design options. So in this instance, we're looking at a comparison between structural systems, a concrete system versus a wood system. We set up a series of models that allowed us to compare the two, and I'm sure, maybe perhaps we kind of assume we know what the output is, but in this instance, modeling practice is actually equally as important as the data. So we realized that we were actually neglecting a really important part of the analysis and had to rerun the assessment to address the differences in the substructure, which allowed us to see more fully the global warming potential associated with both the wood and the concrete structure. We're also able to run whole building life cycle assessments and to then aggregate a series of strategies from substitute cementitious materials to changing things like solid metal panel to perf metal, to looking at changes that might range from PVC roofs to SBS bituminous roofs. So there's a lot of ways that designers can begin to investigate, again, these types of assemblies. Now, we've incorporated over nearly a decade this modeling practice into our work. And for a number of projects, such as the Tidelands, we've been able to use carbon modeling to inform decisions on interior finishes, envelope, structure, and do this in collaboration with a larger team. So in this instance, with our structural engineer, we were able to make significant embodied carbon reductions on the building structural system using low cement content concrete. At North Campus Housing and University of Washington, we used carbon modeling to study assemblies and whole building design options throughout all design phases. And here we learned about the role of carbon neutral materials such as wood, and the need to scrutinize the embodied carbon associated with other material categories like concrete and metals. And at our studio, which I'm sitting in right now, which is the deep retrofit of a 1940s beer bottling facility, which became in 2015 our primary studio, we proved that building reuse is, in fact, the most effective strategy at tackling total carbon. So our calculations suggested here that it would take 183 years of building operations to equate to the embodied carbon saved. So it's important to note that life cycle assessment has moved forward over the last decade as an important modeling practice alongside energy modeling, alongside daylight modeling, alongside a whole other range of modeling practices. And in terms of decarbonizing, what we're seeing is the emergence of standards and methods and approaches that allow us now to do a series of different types of models to start early phase design with, say, whole building models that allow us to look at attribution. We know now how to run models that allow us to look at options and compare options and interpret data to understand optioning. We can go through processes of optimizing, and ultimately, we can begin benchmarking. In fact, we saw some of the first benchmarking studies happen more broadly in the industry in 2017, and those studies continue, which means that we have put embodied carbon modeling we have run embodied carbon modeling through a series of paces to understand how to approach embodied carbon modeling, but we now understand the difference between, say, embodied carbon modeling or upfront carbon modeling, which looks at the initial impacts of building materials. But we also are in a space where we can begin to appreciate what it means for a building to hit a particular embodied carbon benchmark. So likewise, in our practice, we look not only building by building, but we look at building alongside building. So we organize all of our findings into a database, and then we are able to use that database so that we can begin to quickly identify how we're doing compared to other projects. And so in our own efforts, we are trying to organize embodied carbon data across projects and to create comparisons across projects. Likewise, we're organizing energy data. So we're able to use energy modeling findings. We initially focused on breakdowns by end use, which really does help project teams understand how envelopes and ventilation rates and climate can drive key variables like heating and cooling. But more specifically, as our focus has shifted from energy efficiency to carbon emissions reductions, we've increasingly looked to view these same data through the lens of fuel sources. So this shift to fuel sources becomes incredibly important when we consider the carbon emission factors associated with each of these sources. And while on-site natural gas combustion and district energy supplies fueled by fossil fuel combustion tend to have similar emission factors, the electricity grid has widely different emission factors depending on where your project is. And when we toggle to the next slide, you'll see the same project scaled not by energy use, but by operational carbon emissions. So here you can automatically see that the three projects on the left, very far left, see if I can, I don't know if you can see my cursor there on the very far left, also benefit from extremely low carbon grids, and all three happen to be in the Pacific Northwest, where energy is supplied mostly by hydropower. By contrast, the next two are in the Midwest, where energy is supplied by the Mid-Continent Independent Transmission System Operator, or MISO, and two-thirds of whose energy comes from gas and coal. But we can learn a lot by putting these carbon pictures together. So putting embodied and operational carbon findings together, we can start to see across various time horizons which projects have greater share of their total carbon coming from embodied emissions and which have operational emissions contributing to the greater share. And this also comes into clear focus when we view project timelines. And here we have two projects with similar energy use intensity and embodied carbon intensities, but because the left project is in the PJM balancing authority, its electricity use contributes to carbon emissions that will equal embodied emissions after just eight years. And by contrast, the project on the right has nearly negligible emissions from electricity because it is in the Pacific Northwest, despite electricity accounting for the bulk of energy use. So with this larger context defined, we're also able to ask questions about how do we start off projects through goal setting. So it's also really important to be able to pull findings from detailed models. And these sort of comparisons really can engage projects in the future as we think about future projects. So to assist goal setting at the very early stages of design, we've developed a collection of slider inputs that allows one to quickly sketch out and save what-if planning scenarios. And a lot of stakeholders may not necessarily be versed in the impact of a ton of carbon emissions. We've also included two financial indicators: the cost to offset net life cycle carbon emissions through purchased offsets, and the social cost of net life cycle carbon emissions. And these use predefined market rates and social cost rates from the federal government, but can also be customized further depending on client or jurisdiction. So I have about 2 minutes left to wrap up, and now I want to shift the conversation slightly. So as we have normalized the practice of BIM LCA and we've connected models to environmental impact data, we've also begun to shift the conversation using nearly the same underlying data sets with additional data sets to actually look at ways to now not only look at decarbonization, but to actually evaluate building materials through an environmental justice lens. Observing in our work on TALI that while embodied carbon and ozone depletion are often thought about as global scale impacts, it's actually the other impacts that are reported in life cycle assessment modeling, acidification, eutrophication, and smog formation, that are local impacts. And so as we normalize the practice of BIM LCA and we connect models to environmental impact data, their interaction with these underlying data sets does present this opportunity to evaluate materials through an environmental justice lens. And we can directly acknowledge that in the US, Black, Indigenous, and people of color and poor populations accrue a higher share of pollution risks due to land use policy placing, manufacturing plants, and material disposal locations in proximity to BIPOC communities, which means that place and impact and people can be thought of directly in relationship to each other. So we can look back at environmental product declarations and see, for instance, where a material is manufactured or where fuel sources for material manufacture are derived from. And we began to realize that we can, in fact, spatialize impacts, and spatializing impacts could improve an understanding of site-specific toxicity and effect on local communities. And so as we do this work, and this is proof of concept work that we just began this summer, we're looking at mosaicing a range of different types of data to spatialize these impacts and to build upon EBD's strength, which is its hyper-specific in terms of identifying local and factory-specific impacts. And we can then extend a proof of concept method for computational designers to work with LCI data sets and to do it in such a way that we can mosaic with other forms of demographic and health data to establish complementary pathways for integrating place-based EJ concerns into design decision making. That means that we can identify how likely people are to have human health concerns correlated with a type of environmental impact. in a specific location. And while this is a proof of concept, and we are working to increase a number of aspects of this modeling method, we are beginning to extend this proof of concept to increase the resolution of the data, to improve EPD sourcing, to really increase geographic coverage, and to represent materials and product diversity. David, I'm going to hand it back to you. Thank you.
Thank you, Billy. That was the most impressive 20-minute talk I think I've seen. I think we should have given you about an hour because you've got a lot of content there. We have some questions, but as the moderator, I guess I'll take the prerogative. Could you explain to our audience a little bit more about the context of this work? It's an impressive research enterprise that you have there in your office, but is this requested or required by your clients? Is this sort of self-directed? Can you give us more context?
Yeah, I can give context for actually both the projects I shared are primarily self-directed projects in 2008 when we started really just looking at this premise of design for disassembly. That was a discourse that was had emerged fully at that time when we were looking at design for disassembly, but also making an association between the capacity to recover something and its value. That this was very much self-directed, and in our practice we have a research-centered design approach. We have a research group of about 12 individuals in a practice of approximately 90 people, and our work is to both look at or to do research that's integrated into architectural project delivery, as well as look at gaps in the industry and try to understand how to transform practice through different modeling methods, different technologies, different approaches. So this was very much initially self-directed, but I have to say that over time, this work is very much associated with a much, much larger community than in our practice, of course. So yeah, I hope that answers the question.
It does. It does. So we have a few questions. Why don't we start with the simpler ones? There's a
Yeah.
question, if you would clarify, what is the LCA calculator that you were showing?
The life cycle assessment calculator I was showing is a life cycle assessment calculator called Tally, and it's a building information modeling application specifically for Autodesk Revit that is principally distributed through building transparency, which also distributes tools like EC3 and other tools.
Right, and we
So
saw
Tally is the tool.
And we saw their presence there at Greenbuild, which is exciting. And so the views you were showing, that was after you've put the model into Tally, you were just looking at the different options.
We were just looking at the outputs from the model. Yeah, so you could see that we were doing some comparative assessments there. So we were say looking at, okay, if we did option 1 with this type of insulation versus option 2, then what's the breakdown or what's the attribution of impacts across, say, the different systems of the building or across, say, CSI divisions, etc.
Okay,
Yeah,
so what you
showing.
showed
I'm
is
sorry
really,
I didn't go into that in more
no,
detail.
it's very rapid iteration, and that's an exciting
It is.
power of this.
That
And
was
then
absolutely the intent. Yeah.
another one of the easier questions was for your social costs of carbon.
Yes.
The question is, have you used mortality cost of carbon? What metrics do you use?
Oh, I would have to dig back into that a little bit more in terms of what we're using. Actually, I know one of the attendees right now in the audience might be able, I don't know if they're able to answer that question, but
Well, if somebody wants to put a comment in, they can.
yeah,
And
it's
so
the
going,
I think it's yeah, Ryan
well,
Welch is in the audience who developed that calculator.
oh, okay. Well, if Brian wants to put something in the chat window, we could share that.
Yeah, we can absolutely share that information.
Okay. And then there was a question from someone who's been active in this area, who's been involved with the NREL Cambium data for operational emissions and so forth.
Yes.
And he's asking who's working on calculating the time value of carbon such that design teams can take the A1 to A5 emissions and weigh the benefits to B6, B7, B1 plus C1 reductions? This is an expert level question. So
that is an expert level question. I know that there are a number of both firms and entities that are working on time value of carbon right now, and I've seen some of those presentations. And maybe some others out there know specifically which entities are working on time value related issues, but that is coming up quite a bit. And I know there's actually a number of studies underway right now to look at specifically at time value. So I don't have any specific ones to recommend to you just yet.
And maybe this is something, I don't know if it's part of Gabby's talk following this, but with her work at Watt Time, maybe she has some thoughts on that.
I think
we have a little time for a couple more questions. What is your take on AutoCase?
Oh, are we talking about the?
Well, that's all I know about the.
With
respect to detailing envelope materials. Sorry. Yes.
I'm sorry, I do not have a take on AutoCase.
Okay, and that's perfectly okay. Okay, so we see a few other comments. I think maybe we'll hold these until our panel at the end. We're about at the end of our time. So Billie, I want to thank you for your talk, and we'll hold the rest of the questions for our panel at the end.
David, I did just want to mention that Ryan actually did respond to that question about the social cost of carbon.
Oh, I see. Okay, I didn't understand what that was for. Okay, so the response was $51 a ton based on the Biden administration executive order 13990. Okay.
Thanks, Ryan.
Thank you. And then $10 a ton for high quality market carbon rate offsets. Okay. Well, good. Well, thank you. So at this point, I'll ask Gabby to go ahead and share her screen if she's ready.
Thank you. Thanks. First of all, thanks, Billie, David. Thanks, Billie, for the great presentation and sharing a little bit of your knowledge with us today. And first, before I start talking about Climate Trace, I just want to thank everyone to be here, and thanks CBE and PG&E for the opportunity to be here with you all today. Special thanks also to you, David, and all everyone that put the work to put this up together. And well, as mentioned, I'm Gabriela, or Gabby, and I'm a product manager at Watt Time and Climate Trace. By training, my background is mostly in energy engineering, and at Watt Time, along with Climate Trace Coalition, I keep working towards building our database and data products that allows users to direct impact in emissions reductions. So you guys heard me talking a little bit about Watt Time and Climate Trace, and it can all sound a bit confusing if you're not very much familiar with it. But let me explain a little bit more on what is all of this about. Climate Trace is a coalition who members are parts of universities, nonprofits, for-profits companies as well, and among others, and Watt Time is one of the founding members of the Climate Trace Coalition. Watt Time and all of these other organizations, along with the VP Al Gore, group their forces together and their expertise, their sector expertise, to build this comprehensive emissions trackings tools and inventories. And this is what I will be talking to you about today. So our goal in Climate Trace is to provide data that allows decision making and informative decision making. Our data, mostly it is independent. We collect direct measurements and we incorporate that to our machine learning models, and we train our machine learning models based on some ground truth data. Our data set is also timely, which means we have annual data for every country in the world globally. but we also just released, matter of fact, last week, more than 70,000 assets, slashing like factories, power plants, where we have like individual assets emissions estimates. And our data set, one of our goals is also to be comprehensive, like including the major sources and sectors of the economy. So on this graph here today, I'm just like showing you all a little bit of like the climate trace inventory, like our coverage. Our coverage like includes all sectors, meaning sources and emissions that we have models to estimate the emissions for. But for today and for the purposes of this like presentation, I will like to mainly like just focus on the built environment. So the built environment 2021, based on our data that we have collected, more than like around like 37% of annual global CO2 emissions in 2021. And here again, like by the built environment, since like we have like all the sectors, what we are looking at is like activities that are happening in the urban and manufacturing environments, such as like transportation, manufacturing of goods, and environments in all the built environments. In this analysis, we excluded forestry and agricultural activities as well. And here on the analysis like made by the climate trace data, we can see that like building operations, meaning like the use of electricity and the use of electricity and fuel in buildings are responsible for around like 25% of the emissions globally. And buildings, materials, and constructions are responsible for around 12% like for that specific year. The building of materials that I'm mainly looking at here is just the emissions produced manufacturing processes, and that's like includes mainly steel, cement, and aluminum materials as well, such as like sand, like in rock quarries that are commonly used globally too. One other like analysis that we have made that I thought it would be like interesting for us to start like this conversation and showing more like about the climate trace data is looking at the overall life cycle of the construction ecosystem and carbon emissions. So the contribution from raw materials comes like primarily from the energy intensive, for example here like the cement production, and through like also like metals. So about like 50% of like the global steel production is used for construction alone, which contributes to around like 7% of global emissions. And the contribution from like commercial and residential buildings operations is mainly driven by like the space heating, which buildings also like there's like some heat leakages to pour insulation and other energy use, such as like lighting, common and air conditioning appliances. But for today's like purposes, I will be showing you how like just a sneak preview how like climate trace data can help to decrease the 29% of the processing of emissions. So here I brought up like some more other statistics as well on the cement and steel like emissions that like the cement and steel and aluminum sectors contribute like globally. And as we know, like these like three like main materials are materials very commonly used in building construction globally. And on this graph, I have like the temporal carbon emissions of manufacturing cement and steel for the years of 2015 and 2021. Overall, throughout like our data, the industry is like very consistent with the emissions. But what we know that mostly like the emissions, what drive those emissions are the demand for like the products itself. Looking more like, let's zoom in a little bit on like more in the US manufacturing. And what we have here is the same like materials presented before, cement, steel, and aluminum, but looking into only the manufacturing of these materials in the United States alone. And as you can see, there is a little bit of a drop in 2020 data, mostly like in steel right here. I'm not sure if you guys can see like my cursor. There is like a little drop of steel on the year of 2020. And we have seen, this is like annually data, but we have seen on our monthly data that we also like make it available for users, that we can see the drop like in March in 2020, where like when we started like seeing the shutdowns of like COVID, to like diminish like for COVID. But then here on this analysis, I just brought it up, the yearly overall estimates. So then we can see that like how much the industry, like the processing of these materials are generating. So there are some like mechanisms that we can reduce emissions impacts of new like buildings. And there are like we know that these like can help like minimize the emissions within like the building ecosystem. And the main three ones that I brought it up today was material decarbonization, demand parity, and of course like optimizing constructions and materials. But I would like to focus mostly on the material decarbonization section. And with like today's economy, we can see that consumers have most of the power to push manufacturers for like more carbon-friendly alternatives. And by material decarbonization, is to, during like the vendor selection, opting to manufacturers and companies that have lower carbon emissions during its production processes, by applying like mechanisms that increase like efficiencies. There are like some manufacturers like for cement and steel that are starting like by their processes, and that they are starting to procure like electricity that are cleaner, that are not relying on dirty like fossil fuels. And also there are some like other manufacturers that we are seeing that again, they are starting to abandon fossil fuel to heat their furnaces, and doing like other like several technology advancements that can allow like carbon reductions. So all of these like solutions, they can seem like very familiar to some, and a bit like obvious. And the main question is like how can you then like pick one manufacturer to another, or pick one company that has like less carbon footprint than another, and knowing the exactly like emissions footprint of the materials like that it was used in the construction down to like the facility level. So what I mentioned previously, Climate Trace, we launched our asset level platform, and this is like pretty much like right off like the oven. We launched last week. And once you go to climatetrace.org, you can access like freely our data in our platform, and we have data available for download and on the map too. And on here on this like screen right now, you are seeing just like the global view of like all of our data available in Climate Trace. And this includes like all the sectors. So each like color represents sectors. So we have like data for power plants, we have data for steel plants, agriculture sector as well, aluminum plants too. And these like lines across the oceans is the shipping data that we have like emissions estimates as well. So let me show you all like how like Climate Trace website looks, and just giving you like a sneak peek of what you can like access. So once you go to Climate Trace, you have the Explore map or download the data. But let's look at an Explore map right now. Here's like the data, like all the data downloaded. You can choose the data based on like on the filters. And here you can have like the different like countries and regions, and select the sectors, gases as well. Let's select the manufacturing sector that I have been talking so much today, and looking at aluminum, cement, and steel plants globally. So here you can see like where all these three like types of manufacturers are located. And it is a very interactive map. So we have like down on the cursor, we have the ranking. And I click here on our like China, and then go into South Korea, like power plants as well. But let's see North America and then United States too, where like those like power plants are located. So once you do that, there's like, again, the ranking changes, and you can see where those like manufacturers are located as well. Yeah, So so that one was the first one, like the first one of the first capabilities of like climate trace. So it is the map. The other part or platform that we have available is the compare tools. And once you go to the compare tools, again, and this select tool is a compare anything that we keep saying, but like anything. So you can go to our, like you can select a country and region. Here, I'm gonna show you all like more like North, let's look at like a North America, United States. And we can select again, like the sectors, all the different sectors that are available. Manufacturing and cement. And this is like all the assets. This represents all the assets, all the cement plants in the United States. And this is like the total emissions for the year of 2021. And then on the other side, what you can look at is also looking at Asia, and then all the cement plants located in China as well. And then you can see like side by side, like the amount of like how much like the country A or country B or like power plant A or power plant B, cement plant A even B, how much they're like compare with their emissions in the time of the year as well. So yeah, this is our compare tool. Also when you click on these, like I didn't show on this this demo, but once you click on the asset cards, these like tiny cards right here, you can also see the owner of that like specific power plant, meaning like the company that it's responsible for those emissions. And I'll show you soon one of the reasons why, like that's how like that can help like drive some of the aspects that we're going to talk about. Cool. So all of these, this is like all the data that is available, freely available on Climate Trace platform. But how like can this data, how can it be used, for instance, to select different like steel manufacturers by using like the Climate Trace data? So which is like one of the main problems that I brought it up today, right? Like I kept saying like the 29% that it's like responsible for like on the processing of the materials. But here on this graph, you can see that there are different types of like steel plants. So they're distributed like on the different like colors. And as I mentioned like before, there are known like manufacturers there that are starting to electrify their processes. And that makes their like emissions factors, emissions intensities being lower in comparison to be like higher emissions intensities. So on this graph, we have like global steel power plants ordered by the emissions factors. And if you were supposedly to pick a power plant that has, a steel plant that has lower carbon emissions, you would be picking the ones that are on the far left and trying to avoid manufacturers that are in the far right, that mostly are the ones that have like integrated blast furnaces, which uses high intensive like fuel to heat their furnaces for like smelting the steel. So this is like one way that you can look at the data as well. But also like you can still like select steel vendors with Climate Trace data because we have compiled ownership data that allows users to look at the company-wide vendor for the specific steel. So you can see like that manufacturing, where the steel is coming from, who owns that, and who's like selling that steel from like the data. And here, for example, I brought it up. It would be better, for instance, to choose steel coming from the Nucor steel plant instead of the Nippon East, like located in Japan, mostly due to their emissions like factors that they use that are like the Nucor is known to be around 3 times less than the Nippon one, and connect that with the Climate Trace ownership data. So there's like some analysis needed to be done, but it's something that it can be done with using Climate Trace data. Also, I brought it here like another example from like cement, where I have ordered all the cement plants that we have like in our database. And from like the cement plant that we have like on our database, you can still like pick the plants that are located more like on the far left here, and avoiding like cement plants that are more like high carbon intensive. And another example too with the climate trace data is that, for example, here, this pellet plant that emits like 0.75, it would be like a better choice, like picking cement coming from this plant than this one, that it's 1.1, that it's located in Italy. And again, we have like ownership data, like our ownership database, that you can like see who are the company-wide and like seeing like their company-wide emissions for like their manufacturing processes. Of course, like also our maps, our emissions maps, like helps to do like some sort of like other analysis, do like the environmental justice aspects, where you can see which like communities are being affected from like those like cement plants or power plants, and seeing like how like that pollution is affecting the quality of life of those like around or by like proximity for those like sources of emissions. I also thought that it would be like good to explain a little bit how we obtain these emissions estimates from specific steel plants or specific cement plants or aluminum plants, and at a very like more like general and more simplistic explanation, we observe the activity that is generating the emissions. So with like satellite imagery data, we can observe like the ship movements, we can observe like forest fires, and also like sizes of like the sizes of like specific equipment located like on a facility. And then through observing these activities, we train our models to observe those activities, and we complement our models with ground truth data that it's either like has like the amount of like carbon emissions that those industries were like generating provided by from sensors, and we aggregate all of that with like some emissions vectors as well that are specific from the facility, and it's specific from the technology. And doing all of this with like artificial intelligence machine learning, we can train those models to go for areas where we don't have like much data. And doing that, we can get like some like the emissions estimates globally for all like types of like plants. Here, since I have been talking so much about steel today, I thought that it would be like cool like to show you all like how like an imagery, like satellite imagery data would look like, mostly specifically from a steel plant. So looking at this slide here, you can see that there are the hotspots in red, and these hotspots, they represent the amount of heat that the furnaces, when you're like smelting the steel, it's released into the environment. So with the satellite data tells us the amount of heat. We combine that amount of heat with the known production for that plant, and then we teach our models, our machine learning models, to, once they're like just looking at the images of like how much heat it is emitting, how much that power plant, like that cement plant, is producing, like the amount of like cement or steel that it's producing. And by knowing the activity, which is the steel produced, we apply the emissions factors that are specific for that steel plant, and then we obtain the emissions for that specific steel plant. And as a future work, I'm just going to go through, because I noticed that I'm running a bit out of time. As a future work, we are now like trying to estimate not the 29, but like this other part of like the 69, but the 69 part of the 60% of the emissions is covered by the power plant. But we are also looking into AI and machine learning to estimate heat coming out of residential and commercial buildings. And we're running our pilot in Massachusetts and also Norway to know like how much emissions those like buildings are contributing globally. And for our future work, we are incorporating various like inputs of data and we're using like temperature data, population data size, GDP, CO2 regional estimates as well, and also satellite-derived features that you can like detect if it is an urban, non-urban area, the amount of like buildings that it's located, and then you can predict how much like CO2 they're emitting. Well, thank you very much for everyone for listening today, like how like a little bit and learning a bit how climate trace data can help like building experts to choose better like manufacturers for less like carbon intensive. And yeah, I will be like happy to answer any questions.
Thank you, Gabby. Fascinating stuff and impressive what you're able to produce using largely, I understand, satellite data, and there's a lot of questions about that. So confirming whether this data is primarily or all from satellites, and there's sort of a few questions that I'm going to kind of lump together. So have you done any verification of that, and how accurate do you feel that that data is? And I guess there's a new New York Times article that someone cited asking about peer review of this type of method, I guess. So those are some kind of interrelated questions that maybe we'd like to hear from you.
Yeah, those are great questions. In terms of like how accurate, like we have done like some, we have checked our numbers. Part of like we have like done like several either checking company-wide sustainability reports of their like emissions throughout like their manufacturing processes. We have like checked that. We also, for instance, another like analysis that we have done is seeing what a specific country is reporting for the steel manufacturing emissions, and then what that country reported, how much we got it, and we compared like those two numbers, like those two CO2 numbers side by side, and we have been getting like a very good like matching on those.
Okay, and so so I was also impressed to see the variability between what we might assume to be similar products, steel or cement. The slides that you were showing, is that something that's readily available, or was that something that you kind of post-processed for the presentation? For example, being able to directly compare two sites making cement, say.
Oh, like those ones on the video, on the demo, those are available on our platform.
Okay.
So once you go to climatetrace.org, there is on the slide far right of the banner, there is the compare tools that you can go there and compare, even if someone is interested in a power plant, for instance, and like how much electricity emissions are associated with those like power plants, you can compare side by side both power plants, steel plants, or even compare a power plant with a cement plant. That's like something that can be done too.
And then I don't know if this is a question for you or maybe it's for the panel. So this is the carbon emissions or the emissions at the site. So then
Yes.
A designer or a specifier would then have to do the next step and figure out what's the transport impact going from, you know, if this is a plant in Japan or in North America, and where's the, you know, where's it going to be manufactured and so forth. So maybe that's something, I don't know if that's something that you want to talk about or if it's something for the panel at the end.
I think that it would be like great, like talking like and connecting everything like on a panel at the end.
Okay.
Also, when Billie was like presenting, I had a couple like ideas on like how we could discuss too as well, like in her life cycle assessment.
Okay, great. There's lots of synergies there. I guess in the interest of time, we'll hold off on these questions for the panel. There's a few more that are coming in. But thank you for your talk, and we'll revisit these questions in the panel. And then I'll invite Manos to share his screen.
Thank you. Yeah, I'd like to thank the CBE, BG&E for organizing, definitely David for getting us all together and doing a great job coordinating, Tala, fellow panelists. Really great to hear your perspectives and your takes on the issues at hand. And then last but not least, I want to thank Swazik, who referred me to David and who's in the audience, and I'm really happy to be here, and it's all because of her. So I'm going to share, I have a little bit of a different, I guess, perspective perhaps. I'm going to share a few lessons learned from how we've used data and an engaged user base to qualify and execute decarbonization projects using our platform at Station A. 100% of the information that you'll see in this presentation is accessible at stationa.com, and you should all feel free to navigate there if you're interested. But a couple things about myself initially. I love talking about myself, and this is going to be no exception. I am really passionate about environmental design. I studied architecture back home in Greece many years ago, and got really fascinated with the notion of environmental design, the idea of how do we design buildings and cities for climate change. Over the years, I realized that I also had a passion in geoanalytics and essentially broadening out from the scale of the individual building, going to the scale of the whole city or a neighborhood or a region even, and using advanced geospatial analysis techniques to determine what solution, what climate change mitigation solution would work best, where and why. So the science of where, essentially. And in order to facilitate these passions, I've really gotten into software engineering over the last 10 years. My goal is always to leverage cutting edge technology for social good. I'm a very big fan of making data accessible and making information easily digestible. And so a lot of this presentation is going to be about how do you communicate information and what have we learned by doing this at Station A for the past 7 years. And so a couple things that I will cover today. Number one, the state of the decarbonization project qualification and execution today. So why is qualifying and executing decarbonization projects so hard, and why does it matter? The second part is going to be about Station A, a company that I co-founded 7 years ago. What have we tried at Station A? Where have we failed, and where have we succeeded? And then I'm going to spend just a couple minutes talking about where I see the future of decarbonization analytics going. So how can we scale and expand building decarbonization using a tech playbook? So using learnings from other industries that have succeeded in broad dissemination of information, how can we actually use these techniques to push forward like the virtuous goals that we're pursuing with decarbonization? These are probably going to be pretty basic slides for this audience, but I just want to frame the context within which our company operates. About 70% of carbon emissions are related directly or indirectly to electricity generation in buildings. Gabi did a great job showing us like highly granular data around this. At the same time, only 10% of global electricity generation is clean. I'm excluding nuclear, but I'm including solar, batteries, wind, and geothermal. Most of the electricity generation globally today is still coal, oil, and natural gas. What is different now? Well, three things, according to us. First off, clean energy is more affordable than ever. A staggering, like completely fascinating statistic is that 10 years ago, it was 82% more expensive to build on-site solar, for example, in a building than it is today. That's like a phenomenally large number. The market is an untapped market. A good project, a good decarbonization project has a really short payback period. However, we are seeing that only 3.5% of the on-site clean energy market has been tapped. And that is information coming from Station A's data and analyzed by Wood Mackenzie. At the same time, we have a cultural and moment around decarbonization. Decarbonization now is a compliance issue. The SEC is requiring public companies to measure and report emissions, as you all know, and we've seen that 88% of public companies have ESG initiatives. but only 39% of them believe they're effectively meeting their goals. And so this is the environment that we find ourselves in, and it's really what becomes really apparent is that it's not an issue of cost, it's not an issue of value proposition, it's not an issue of policy. So then why are decarbonization projects so hard to qualify and execute? According to us, it's the data, the software, and the process, and that's what I'm going to argue for today. We have fragmented data, clunky software, and broken workflows. Anybody who has tried to analyze a building for a variety of different decarbonization measures can attest to that. We have, at least in the realm of clean energy procurement specifically, we have very non-standard roles, projects, proposals, and contracts. If you try to apply, for example, solar on 2 buildings, the projects are going to look wildly different. The proposals you're going to receive are going to look wildly different, and there's no source of truth for how we should standardize that information. Last but not least, unequal access to data and insight. You need to have, like, a lot of this data is paywalled, a lot of this information is like really hard to access. And so why is that important? According to the Wall Street Journal, from the total cost of a decarbonization project, as much as 60% of it is what's called soft. And so this includes analyzing and building, coming up with a decarbonization strategy, sizing the system to be installed, reaching the building owner, communicating the value, and signing contract. And so this is a phenomenally large number. If we can really make this process and the data more accessible and the process more efficient, we could probably shave off a very, very large number on the dollars per watt, for example, for solar. We can make it as much as 2/3 cheaper, of course, assuming that the savings are passed down to the consumer. A little bit of a closer look into what I'm talking about. This is an industry of spreadsheets. We have data that is sparse and harvested from multiple sources. The average seller, for example, for a product like solar or batteries, uses 10 different software tools to produce a proposal. And the average workflow takes about 6 to 12 months, from collecting data to putting together proposals to refining proposals with actuals, etc. At the same time, everything is a snowflake. I put a snowflake background on this slide just to illustrate that, but every project is a one-off. Every contract is a snowflake. It's pretty unique. Hardware sellers also develop and install. There's no role specialization. And so you will see certain companies that manufacture, for example, solar panels, also try to develop projects. And then you also have the phenomenon of sellers also playing the role of biased advisors. So instead of an example from an adjacent industry would be if you were trying to buy a car, and instead of going to CarMax or cargurus.com, you go to Mercedes or Tesla and you ask them what car you should buy. And so we view this as a sign of an industry that hasn't fully matured yet. And then unequal access to data and insight. Not everyone can afford consultants. Small buyers lack the sophistication of a dedicated energy team. Small sellers can't access clean energy buyers at scale. A local solar installer can't access the same clientele that a national installer can access. And then channels such as utilities don't always provide full transparency, or energy services companies. And so within this environment, Station A was started. We got started in 2015 as an innovation team within NRG. We spun out of NRG in 2018 as a startup. We're based in the Bay Area still to this day. And we are reframing how decarbonization projects are qualified and executed on. And so we use data, like really large data sets, to identify the decarbonization potential of C&I buildings, commercial and industrial buildings. That's where we're focused today. We have a patented blend of geoanalytics, energy modeling, and predictive simulations that help us determine what's most valuable where and why. So this is the qualifying of projects piece. We use that data as a foundation, and on top of that data, we have built a user network that connects to actually execute on projects. We believe that our CEO, Kevin Berkemeyer, says that climate change requires action, not just reporting. And you know, I'm a very big fan of that phrase. So we have launched a first-of-kind decarbonization project marketplace, where clean energy buyers, such as real estate owners, and clean energy sellers, such as financiers or installers or developers of decarbonization solutions and clean energy solutions, connect to execute our projects, and we facilitate this process. Last but not least, we help cities, utilities, and regulators make data-driven decisions for the future of the grid. So we provide our technology to users who would otherwise use Microsoft Excel. Love Microsoft Excel, but not good for everything. If you look at our evolution over the years, we've been doing this for a while. We started in 2015. So in 2015, we built the first iteration of our data ingestion and indexing pipeline. We started harvesting and organizing building data at scale, collecting building footprint information from local county data repositories and sources that you all are pretty familiar with. In 2016, we launched the first version of our building energy modeler. So we started looking at building electricity usage and modeling a variety of different products on top of that electricity usage: solar, batteries, EV charging, etc. In 2017, we launched the first version of our web application. It was a web platform to help clean energy sellers at the time find leads. So you would log in as a seller of solar, for example, and you would search across our very large data set of buildings to identify what to sell, where, and why. And then from 2019 until today, we started learning from user intent data, soliciting actual market quotes for projects, and training recommendation models. So one of the things that's pretty interesting about Station A is that we have been operating as a web app for a very long time. So we have a really interesting user interaction data set that we are using to learn from and to make inferences from on a continual basis. In 2021, we launched our marketplace, and we started connecting users and running project transactions digitally. And so we are way more than just a lead generation tool today. We are a qualification tool, but also an execution platform. And so not only can you find what's best for your building if you're a building owner, but you can also run digital RFPs, connect with sellers, and choose the best option for your building. I'm going to present 3 lessons. A lot of these lessons are I'm a designer, and I have a background in product, and so a lot of these learnings are very much related with the way the information is presented and the strategy behind the product. But lesson number 1 is that how you present the data is as important as the data itself. So we have a mantra at Station A: lead with intuitive metrics, lower the data barrier to entry, and refine data over time. What we've seen a lot in our industry is hyper-accurate, engineer-vetted quotes that require a ton of information up front in order to be produced. That really slows down the process of selling these solutions. It's really important that we move these transactions as fast as possible. And what we've instead done is just with the building's address, we can produce qualitative metrics such as our building energy grades, and invest in buyer education, refine our numbers with actuals at a later time, but essentially use these building grades as a way to start a conversation with the building owner. We have had phenomenal success with this. Our building grades lead to a follow-up conversation with a buyer 86% of the time. So we found this data to be extremely interesting and engaging. It wasn't always that way. This is a small video from Station A web app version 0.x around 2017. We used to have a pretty clunky map at the time, and you would essentially build your geographic area of interest, and you would be able to see all the buildings within that area. As you can see here, we had a ton of information that we would provide to our users at the time, including electricity usage estimates, including which utility territory they're within, what's the grid capacity at their location. We would then train a similar buildings model on top of that data. And we even had a very, very detailed annual solar and battery dispatch simulator that would show you, essentially how a battery would operate for every hour of the year in that location. And so an extremely detailed and kind of overwhelming tool. And fast forward to today, where we've invested in this much simpler and more accessible way of displaying the information. This is the third major version of our web application, launched in 2021. You can all access this on stationary.com even without an account. But essentially, you can see how we are essentially mapping all the large buildings within a geographic territory, and we're attributing what we call clean energy grades. And these grades are anywhere from A+ to E. They reflect the building's electricity consumption. They reflect the local policy incentives. They reflect the type of building that we're looking at, the amount of space on the roof, the amount of space on the parcel, and they essentially indicate a building suitability for different decarbonization measures. Each building is represented by a card, and these cards are continuously updated as new information becomes available. And so if you have a favorite building, you can navigate, you can see it, you can bookmark it, you can come back to it at a later time and see how this information has changed as our models get more accurate, as new offers come through our marketplace. And so looking at this transition from where we were before 2021 until today, we used to have a product called the stationary place cards. Stationary place cards were first released in 2016, and we started sunsetting them around 2021. It was a very overwhelming product. Here's everything we can infer about a building. Go have fun. We used to, you can see a screenshot here on the left, we used to show numeric data with very high precision. We used to ask users to browse for buildings in a list instead of a map. We would just literally take all the data that we had and just put it on a page. We would always show all the information at once without any context, and we would kind of wait for the user to ask questions. We learned a lot from this experience. What's really amazing about having a web platform, and the amazing thing about the internet, in my opinion, is that we can actually really quickly test and iterate. Billy talked about, I think, the speed of design. Like, what's really cool about this stuff is you can really iterate really quickly on what a product looks like. And so in this new building grades product, we started showing qualitative data representing ranges. So instead of telling you you're going to save $1.52 million, we started saying we think you can save 10%, or your building is an A or a B based on like your range of savings. We enabled map-based navigation, which is way more intuitive for users. We're empowering users to discover data themselves. We emphasize key metrics instead of really broadly showing all the data at once. And we also have the ability to show contextual FAQs that help guide the user experience. Lesson number 2, standardization is the only path to scalability. This is something that is really needed. We have really pushed for standard data schemas, account verification, connecting users. These are things that we're doing within our platform. Account verification, a very interesting hot button topic these days. But we've been building a user network over the past 5 years, verifying accounts, learning from historical user activity, and standardizing rules and proposals. What that means is, if you are a solar installer that created a stationary account in 2015 and you've been using our application over the years, now that we have our marketplace product, we can recommend which buildings you should be looking at based on your interaction history. And once you look at these buildings, we can essentially notify the owners of these buildings that there's interest. So trying a lot of different ways of building engagement on this platform. What's really exciting is that with all this data and all this context that we have about our users, we are able to get to 100% close rates on projects that are actually listed on our marketplace. So if a building wants to implement a measure, we qualify these projects really well, and we have 100% close rate in terms of getting term sheets signed between a clean energy buyer and a clean energy seller. This is just a view of our marketplace mode where you can see how the information is displayed. And so we standardize what a project looks like, which is such an obvious thing, but surprisingly doesn't exist today. So each project has a set number of key metrics such as the annual peak in usage, the preferences of the buyer captured down here. We have brief summary statement around the project, the specific timeline around the project, and then all the proposals that come through have a very, very specific structure. And so overview, design, financials, as you are bidding on these projects, you can essentially structure your proposals in a very uniform way. Of course, there are specific requirements in certain projects, and we have a way to flexibly adapt these data schemas to accommodate obscure questions as they come up for certain projects. Some impact metrics. We believe that standardizing roles and proposals across solutions unlocks scale. To this day, we've onboarded about 2,000 providers of decarbonization solutions, including the biggest names. We support 5 different solutions today, including on-site solar, EV charging, off-site PPAs. And what's really exciting is that if Station A were a seller of clean energy or decarbonization solutions, we would be the 11th largest seller in the nation based on megawatts installed. And this is only within a year of our marketplace's launch. This is a really phenomenal statistic, especially given that we are an extremely small team of 14 people. Lesson number 3, data openness levels the playing field, encourages competition, expands reach. I can't emphasize this enough. Burn the paywalls, simplify the user on-ramps, integrate information everywhere. Contrary to what most users are accustomed to, we don't require a credit card and a lengthy sign-up flow to get started. Making our data accessible without an account has led to about 171,000 engagements with our data within the first month of launch. If I Google search the address of a large commercial industrial building in Google on the left-hand side here, you can see the stationary result come up, much like I would be able to see the Redfin result come up for my home or a Yelp result come up. Station A essentially allows Google to index this information and makes it really discoverable for a broad audience, anybody with an internet connection really. So here we can see this building in Commerce, California. When I click on it, I can see the card pop up on the right-hand side. Providing equal access to data and insight for anyone with an internet connection again, really passionate about that. Station A to this day has mapped 140 million buildings. We have evaluated about 1 million of these for different decarbonization measures. And what's really exciting about this data set is that we have the ability to know within a reasonable amount of certainty which buildings would have positive first-year returns. And so we've identified about 750,000 buildings in the United States that today, if they were to implement certain decarbonization measures, they would get to 750K to, positive first-year returns. The combined capex of all these projects would be about $200 billion. And again, 171,000 buildings viewed in a month. If this information was behind a paywall, that number would have been 0 or very low. So Station A, this is a snapshot of our company and our products and our data. I think the most important thing for us is that we, again, are a team of 14. It's been really incredible to see what we can achieve with such a small team, and so much of that is because we really rely on data automation and software to make clean energy and decarbonization product buying and selling super easy and bring it to the 21st century. Where do we see this going? So a couple of things that we've done and that we've proven over the years. We've patented a data pipelining and processing technology. We've scaled an engaged user network on top of that. We were able to run our first all-online project transaction in 2021. What we want to do is we want to expand to more decarbonization solutions, energy efficiency. We've already gone into EV charging and community solar. We want to do offsite PPAs. And then last but not least, digitize and streamline more of the transaction user experience. We believe that the way you buy solar and the way you decarbonize your building is going to feel a lot like the experience of buying a flight. Of course, we're talking about $1 million purchase versus maybe a few $100,000 purchase, but the principles are the same: transparency, access to information, a digital process that is facilitated by humans, but largely is digital and online. Thank you so much. Please follow Station A on all the social media, and also our GitHub has a number of open source projects that you all can fork and use. Thank you.
Wow, that is very impressive. Thank you, Manos. We have time for a couple of quick questions. And I had one. You mentioned that you have 5 solutions, but is battery storage one of those?
Energy storage is a model that we're going to be launching really soon. Right now, we are vetting it with some of the providers in our network, but we support solar today, EV charging, community solar, and offsite PPAs, as well as carport solar. So different flavors of solar, as well as EV charging and offsite PPAs is where we are today. But we intend to keep expanding this library of products, and we intend for these grades to represent the aggregate potential for the building across solutions.
And then another participant asks about your business model and how you generate revenues.
Oh my God, I could talk all day about that because I'm a founder, so I'm very involved in fundraising, as you can imagine. Maybe you can tell, but Station 8 today, Station 8 traditionally was a SaaS company, so we would charge money to access the platform. Today, Station 8 makes money as an originator of projects, so we get paid from the sellers once term sheets are signed. And so we collect a fee when the project closes. And why that's really exciting, in my opinion, is that if we can make money by the projects, we can actually make the data free for everyone. And that's really exciting.
And then we have a question about whether this tool has been or could be used to map electrification retrofits.
We definitely have modeled the current electricity consumption of, I think, large commercial buildings. We haven't I'm not sure what the person's referring to, but we certainly could. Like an electrification retrofit could certainly be like one of the solutions that we include within our platform. We have that tooling. We haven't done it yet.
Okay. Well, thank you. And we may maybe I'll hold off on these other questions just in the interest of time. We'll hold them for the panel. And so thank you, Manos. So we'll hold the questions to the discussion, and we'll invite Mark to share his screen.
Yeah, thank you, David. And thank you for having me to the CBE. It's been really cool to see these other projects. What Billie's working on with Tally, the full life cycle, is very cool. And Gabby, and seeing how we're going to get better carbon factors and be able to see the full life cycle is very neat. And Manos as well, and I'll touch on that later. I'm Mark Siemers, Director of Engineering at Measurable. And what we focus on is the operation of the building. So when you talk about that full life cycle, we're talking about the middle, when people are using the building and the energy it uses during that time. And we've been around for about 10 years, which falls in line with the same timeline of the real estate industry really getting involved with decarbonization and going green. And so that's how I've got the presentation structured, is the timeline of Measurable and the real estate industry. The distance past, we won't talk too much about, but it was worth calling out that there was a time that this wasn't a consideration for the industry. And then more recently, a lot of attention has been given to the problem of decarbonization, and we'll talk about how that's led to the need for quantification, and then that'll move us into the present, where we can cover the effort to decarbonize using the tools of data science at these 3 different levels, and how that moves us towards action and incentives. And the future I didn't put in here, we'll talk about that when we get to it. So the recent past, obviously everybody on this call is giving attention to the problem of decarbonization, and there's always been that aspiration to do that. But the question was, what does it even mean to be green, other than putting in a statement that that's your intent and all of that? And so as the industry started to think about this definition, a lot of organizations popped up, and probably a lot of people are familiar with these. And this helped us define, what does it mean to be green? What measures do you look at? What's a framework for thinking about this? And depending on the organization, you might get a benchmark for that, or a certification, something like that. Using GRESB as an example, That was born out of interest from institutional investors like pension funds who have a 20, 30, 40-year timeline, which is very much in line with caring about the effects of climate change on these longer timescales. And so these organizations have done a great job moving the industry forward, and it's created this challenge of quantification, right? So let's say now you know what to look at, you have the interest and intention to do this, but now you have to solve these problems. You've got 100 buildings across 17 different states. How do you even begin to collect accurate and timely data on those things? How do you analyze the data once you get it? And then how do you benchmark it? How do you know how your buildings are doing compared to each other and compared to the industry itself? And this challenge is really what led to Measurable being formed, and that is what the core of our product has done for the past 10 years. It helps you do that data collection, analysis, and benchmarking. And we've done a good enough job at this that we've had enough customers trust us with their data that we now have information that represents over 15 billion square feet of real estate, or the built environment, as you might say. And once you get that amount of data, that uncovers the opportunity to go from data collection to data science and to use those tools to further advance the industry. And so that's going to be the meat of the presentation here, is how we've gone from that past to this present and how it's going to move into the future. So if you are a data scientist, this might be the most interesting slide in this deck. And I'll talk in more detail about what these are. But essentially, you need a lot of data to make this happen, and then you can train machine learning models. You can monitor things in ways that were not available to us with standard data analysis and a human being monitoring things and making decisions. So, as I mentioned before, this opens up opportunities at 3 different levels. And so put yourself in the shoes of a portfolio manager. If you already are one, then just play the role of yourself. At the meter and management level, there are tools that exist now that weren't available before that allow you to make decisions and take action in a way that just wasn't possible before. At the market level, there are also tools available there that both present an opportunity but also might apply a little bit of pressure to those that are at the portfolio and property management level. And we'll talk to that about that as we get into this. So here we are at the present with management. What we've been able to do is use machine learning models to create better baselines for what we call cohorts. And as a portfolio manager, what this lets you do is focus your time and attention, right? So before, you might not know how to compare a stadium in San Francisco versus a multifamily rental in Seattle. Different use cases, different sizes, different climates, all of those things. And so what we're able to do is take the tools of data science, use machine learning models, set benchmarks, quartiles, and things like that to place your building apples to apples in its segment, essentially. And so you can look at this and say, okay, my top performers, either I don't have to worry about them, or maybe I take some learnings from them. I find out what it is about those buildings that make them perform so much better than expected, and apply that across your portfolio. On the flip side, you might look at your bottom performers, and that's where you need to focus some attention. So maybe 10 Main Street, you decide to divest in that. It's maybe too far gone and you can't help it out. Or maybe you look at these and you decide to take action. You use Station A to find, your A+ buildings where you can get a high return off of a solar array on your roof, and then move that from a bottom performer to a top performer. You also might be able to address things with the equipment that you already have, and that's going to take us to the next part at the meter level. And this is a tool that we have, we call it asset optimization. And we get a feed of somewhere north of 200,000 meter readings a day across all of our customers. And we have models built that can measure baselines and also inform you on measures that you can take to address things. So this is just one example of our models noticing something that was unexpected, a pattern that it did not expect to see, that might not be obvious to someone, or it might just be that you're not monitoring it all the time. And what data science allows us to do is be way more timely and way more efficient with these kinds of monitoring. So you're going to get way fewer false positives. You're not going to miss opportunities, and it's going to be very timely and very specific about how you can take action. So we'll zoom in on this example a little bit, where from taking this one recommended action, you can save up to 37 metric tons of carbon equivalents. Also, you get some cost savings in there. And this is with equipment that you already have and personnel that you already have on site, just changing something about how things are working. And so this is really helpful at the meter level, again, to bring up maybe part of your portfolio that's not performing the way that you want it to. And so at the meter level, can that add up? We looked at one example of something running off peak in a way that we didn't expect it to, and potentially saving some money and some carbon emissions. But when you take these in aggregate, what do we get? Well, so far, across our entire customer base, over 42 million in identified cost savings, and over 54, almost 55,000 tons of CO2 in avoided emissions. So even though 1 meter is small, when you're able to take action in a timely manner, it really adds up over the portfolio and over the industry. So that now brings us to the market, where more and more non-financial data is impacting financial outcomes. And we'll talk a little bit about that as we get into things. So this is an example of, we have machine learning models that can take a small set of information about a building and provide very accurate estimates of energy and carbon emissions. And the carbon emissions are based on the energy output, and then it's multiplied by a carbon factor, which were talked about in some of the previous presentations. And this gets more and more accurate as we add more and more square footage to the data set that we have. And as Climate Trace continues their work to make carbon factors more accurate, this is going to get better and better. But it's already in a place where it's good enough that players in the industry are using it. And what's important about this versus the portfolio, the management and the meter, is this data is about a building that I don't have ownership or control over. I don't know anyone that works in this building. Well, I know one person that works in that building. We'll talk about what it is. This address might look familiar to some of you if you're at all into politics, and if not, I brought an image to drive it home. So I didn't have to bribe anyone in the Secret Service. I didn't have to hack the NSA servers. This is all very easily attainable public information, and I was able to generate a report that shows me the expected carbon emissions of the White House. And this means that anyone in the industry can do this for buildings that you're managing or portfolios that you're managing. And there are a lot of people that are interested in this. This is a non-exhaustive list of people that are already using this data or are interested in using it. To pull out a couple of examples, you can imagine an insurer. Their actuaries are interested in assessing risk, and your carbon output is increasingly something that they consider risky. So they may use it to decide if you are worth insuring, to raise or lower your premiums. Same thing with lenders. They might see that buildings that have a certain carbon output are higher risk of default. So they might not see you as creditworthy, or they may give you a higher interest rate to bake in the risk to lending on your property. So just to state this again, the players in the market, they want actual data, but they don't necessarily need it to make decisions. The accuracy that data science has brought to the table is good enough to drive those decisions. So let's say that you've done all the good work that you need to do. You've done a life cycle assessment using the tools that Billie and her team are building at Tally. you've identified great projects using Station A, and you've done all this work and you've created an outlier for your building, and you are beating the estimates. So what's going to happen in this scenario if the market is looking at this estimated data, making decisions about your buildings without incorporating the work that you've already done? And essentially what this is leading to is you're going to have to show them the real data at some point. And we think that this is where the industry is going, using estimates where they don't have the real data, but then pushing for the real data when that is the when that's possible. So I hope that didn't scare anyone too much. If it did, I wanted to give you a brief aside about the Cincinnati Zoo and go back to the past of ignorance and apathy. And the Cincinnati Zoo 15 years ago or so didn't have anything on their radar about sustainability or being green. And there was an enterprising individual that worked in their facilities department, and he started looking at the data. It started with water bills, and it led to them finding out that they had a water main break. And their estimate is, this was about 2008 that they discovered this, and their estimate is that it had probably been leaking since the 70s, and that it just never got addressed. No one was paying attention. They just paid the water bill and didn't think about it again. And that discovery led to a correction. It saved him a bunch of money. So then when he went to go for the next sustainability project, it was approved right away, again and again and again. And then they became the greenest zoo in America. And this has been like, I don't know, 7 years running. They've got one of the biggest solar arrays in the country. They do a lot of community projects with green spaces and things like that. And probably if any of you have heard of the Cincinnati Zoo, it's because of Fiona. And this is just to highlight that you can go from apathy to excellence in a very short amount of time. And the reason that you can do that, oh, sorry, I got ahead one slide. So bringing it all together, we've got things at the meter, the management, and the market level. So you can take time in real action, like we noticed. You can manage your portfolio in a way that you couldn't before. And then the opportunity in the market is to beat estimates, to outcompete for capital. So if you think about the way that public markets work, when you beat your estimates for earnings quarter after quarter, year after year, you perform better than everyone else in the industry. And we think that that's where it's going to go with carbon as well. If you beat your estimates time and time again, you're going to be seen as a leader in the industry. You're going to outcompete for capital in private equity markets, in debt markets, all of those things. And part of that is going to be transparency of showing the real data and the work that you've done. So with all that said, to bring this to conclusion, both for my presentation, but I think also for the other presenters on the panel, we've hit a time where there have never been better tools to address this problem of decarbonization. And with that, there's never been greater demand to prove that you're using those tools to meet this challenge. And David, with that, I'll pass it back to you and see if there's any questions.
Thank you, Mark. Yes, we do have some questions, and let's talk about your questions before we break to a panel. So you noted that, of course, the benchmarking is very important. And we know that buildings are very, very, very variable, extremely variable. So could you talk a little bit more about what your estimates are based on?
Sure.
Yeah.
So the key data points that we use right now are the location, and that drives weather data that's incorporated, specifically degree days. We use the year built, that can change basically the makeup of the building. We use the property type, the use type, and the square footage. So those are the key points that we use to drive our machine learning model.
And so is this validated with either customers uploading their data, or again, it's similar to questions that we saw for the climate trace, but is there sort of the ground truth, if you were? Do you check this in some way?
Yeah, absolutely. And so a couple things on this. Our data science team, who is great, have published white papers on this. and I'm happy to provide that for people that want to get into the details. And yes, it is validated both against the real customer data, the 15 billion square feet of that we have has this data, right? It has real utility data, and we're able to check against that. The R-squared value of 93, that is essentially against the real data that we have. And then our data scientists are also very hungry to go out, and so they find publicly available data. Some states require that you essentially publish your annual emissions or your annual energy usage. And so where that's available, we will test our model against that as well. So we both use our internal proprietary data and then any publicly available data that we have that has enough of the data points that we need to do that validation.
And then we have a question about Levi's Stadium. You use that as an example, and the participant says, well, that's one of our projects. And so, you know, something like a stadium is a very unusual kind of a building. You know, how do you make estimates about buildings like a stadium or a theater or a library, what have you? You know, certain things we would expect would fall in line, like an office building, or maybe even a medical office building or a school. But there's so many unusual cases. How do you suss that out?
Yeah, it's a great question. And before I answer it, let's just say anything in that presentation is fictional in that case. So any representation in real life is just a coincidence. That slide in particular was our demo group that we have. As far as how do we provide estimates for an odd building like a stadium, or we have one property type that's an ice curling rink, if anybody got into curling during the Olympics. So the answer that we have to that is we have something like 112 property types. So they get pretty specific. And as far as a stadium goes, I'd have to check this. We have to hit a certain threshold of proprietary data that we do have for a property type before we provide an estimate for it. Otherwise, we fall back to a higher tier, right? So a stadium might be considered like a recreational or other. But if we have a high enough number of stadiums in our data set, then we can predict for that type of property use.
And are you focusing your energy, or your energy, so to speak, no pun intended, your work on projects that potentially have more benefit from taking advantage of improvements?
We don't, like, are we putting our focus on that? Our focus is to provide as accurate estimates as we can. We are somewhat agnostic in our machine learning models to what's the greatest opportunity. Presenting the data to our customer should help identify the greatest opportunity, and then they can put the focus there. I'm not sure if that answers the question.
It does.
But we try to be agnostic.
Maybe it was a little naive of a question. Considering that it's machine learning, you're trying to do this as broadly as possible.
Yeah.
And then there's a question related to sort of this idea, and you mentioned that there are certain data sources you may have available. And the question is, are real estate portfolio managers taking into account emerging carbon or energy efficiency taxation policies, such as New York State's Local Law 97 or Cambridge, which has a building energy use disclosure ordinance? So maybe the question was first to, are you taking advantage of that in your data sets and your data development, and is that having an impact?
Yeah, so it's as far as the estimates go, we don't have an output that says this is how much it's going to cost you, but this does tee up nicely for a product that we offer. So our data product itself has the energy estimates, the carbon estimates. It also does what we call an ordinance lookup, a certification lookup, and physical climate risk. So a full report will include those things. And specifically for Local Law 97, the measurable core product has a full feature set with that helps portfolio managers identify whether or not they're subject to local law 97 and what the costs will be. So for that very specific example, because it is such a high value to know about, our core product has a feature specifically for it. But again, the estimates are agnostic to how much it's going to cost someone. They're just trying to say, you give us this information, we'll tell you what your carbon output is, what your energy usage is, and then we can tie it together with other features that we have about the ordinances that you're subject to.
And is that information available for your customers or your subscribers, or is some of this more freely available?
So the things that I've talked about are available to our customers or subscribers. The data product itself, to get the estimates and things like that, you don't have to be a subscriber to the core product, but it does have a price associated with it to get access to the data.
And then a participant asks about, are you starting with or using CBEX or eStar data to begin with, and then adding in actual bills?
So we have an integration with eStar. So a lot of our buildings do begin with that, but to get to the heart of the question, utility bills are the source of the data that we use for real energy usage.
Okay, thank you. And then I guess maybe some of these other questions, I guess the second part of that, whether you've seen any changes during the COVID era bills over the past 2 years, and what, if any, effects those are happening. And my understanding is it hasn't changed a lot because the heat was still on or the air conditioning, but what is your perspective on that?
Yeah, you do see a dip, and honestly, a lot of customers of our data product, they care about 2019 data and comparing trailing 12 or 2022 to 2019 because they see 2020 and early 2021 as anomalies, essentially. And so we do see a dip. It may not be as significant as you would think or hope, but we do see a drop, yeah.
So the building baselines are fairly high. Is that what you've observed? The dip is not as...
It's not significant, but it's noticeable. I mean, it's shouldn't say it's not huge, but it is material.
Okay, and then last question until we before we go to the group, and I'll just pose this question as it's written. Is it possible to scale this tool to a city level?
The way the tool is built right now, it would require those bits of information for each building in the city. And again, that's really address, or if you have lat long, that works location generically, the year built, the square footage, and the use type. As far as doing it at the city level without having that information, it's an interesting idea. We don't have that ability right now. We do it at a portfolio level for like publicly traded REITs, but it's because we have a lot of that information available. So it is again a data collection problem for that specific question. It's still at the data collection challenge phase.
Okay, so a portfolio level is the largest sort of scope that you can roll this out to.
Yeah, with a reasonable expectation of being able to do it, yeah.
Okay. Well, Mark, thank you. I think at this point, we'll move on to the full panel. And so I'll invite all of the speakers to turn your cameras on and microphones. And I have a few questions, and I'll invite the audience. We've had lots of questions coming in. I know we haven't had a chance to address them. I think maybe what we'll do as a starting point is I have a few questions that came in after the Q&A kind of wrapped up. And so maybe we'll start with some of those. And I've got a couple of questions for Gabby. And the question is, how do you get the data to train the models that you're using in Climate Trace?
That is like a great question. So we have partnered up with a couple like organizations. We either like buy, there's like proprietary like data that we either like buy that data from, or we get like data donations. So there's like some industries that would like provide their data for us, so we can like train our models as well. For the power plant, like specifically,
Actually,
there are
Gabby,
a lot.
oh, okay, it just stopped. So, okay, why don't, sorry to interrupt you, but there was a bit of a tapping or some background noise. Yeah.
Oh, I'm sorry. Maybe I don't know. Maybe it's me. Like there's a streak on the back. It can be noisy. So I was saying like either we get like data donations from data donors, or we scrape a lot of data. There's like some like for globally a lot of like power plants. They're either like their countries, they release their power plant specifically generation and their activities, and then we can like we built some like web scrapers that we can get that data as well, like for training our models.
Okay, and then the other question for you again, Gabby, is about the production level data. How much do you have data on how much material each plant produces? And I guess the idea is that would, I guess that informs the emissions per unit of material or product.
Yes, we do. That is like actually what our model estimates. We estimate like production level of like steel plants or cement plants, and we use that like various like satellite imagery data that we collect. Like there's some plants that it is like every week, or like there are other plants that we can get like satellite imagery data like for like 3 times like within the same week like period. And then the production data, we can estimate that on monthly basis. So every month, like we have like production data available, and therefore emissions available as well.
Okay, thank you. And then one other specific question, and this came in for Manos, and the question is, could you talk about your product, your database, compared to the Google Project Sunroof? And maybe you could explain to the audience what that is. And the question was, the participant was poking around and found some things that seemed to make a lot of sense and others that they were curious about. So maybe you could explain that to our audience.
Yeah, thank you. Thank you, David. And thank you to the participant. It's like a great question. So Project Sunroof, my understanding is Google's product that allows users to pan around a map and look at solar potential for buildings, and has like basically like a calculator that can enable you to estimate savings with solar. I think the answer to the question is actually in the question itself. And so the Station A grades buildings not just based on the geometry of the building and the availability of rooftop area. The grades rely on how many financially viable options does the building have beyond just solar. So that includes solar, that includes batteries, that includes EV charging. And to bump a building from a D, for example, to like a C or a B, that is a function of the NPV of a solar project. And so it's a financial calculation. And so it's not, you can't determine the grade just by looking at the building. It's really a financial way of measuring, decarbonization project feasibility there. And so that would be the main difference. Other differences with Project Sunroof include the fact that we actually, we don't only qualify projects, that we actually help with execution on projects. And so once a project's been identified, we actually run RFPs, we connect supply and demand, and we sign term sheets, and these projects actually close and get constructed. And so that is back to the question of how we make money as a business. And then beyond that, we have a tech agnostic view of the problem. We don't care to sell solar, we care to decarbonize buildings. And so today we support these 5 solutions I talked about, but in the future we want to support a wealth of other solutions. We believe that, we believe that we don't have any technological bias. We think of ourselves as a Google Maps for decarbonization. You put where you are today and where you want to be, and we'll give you the best path to get there.
And then a follow-up question for Manos, but I'm actually interested to hear if other folks have thoughts about this as well. The use case that you presented is a building owner. I think the main use case is a building owner. So I'm running a shopping mall, let's say, and I use the tool and it says that I'm an A. And so I'm going to, log in and create an account and get set up to receive these offers. But it seems like it could also be used, there could other use cases, like a provider could find an A or an A plus and then make a pitch directly to, track down or make a pitch to a building owner. Is that something that you support, or is that maybe something for the future?
I mean, yeah, this is like a great question. It's like the classic disintermediation question in marketplaces. What we care about is for projects to be built. And so if our data is used to build the projects without us getting involved, that's great. I would say that we haven't had that happen mostly because the quotes that we show that are related to the grades are generalized and they're not, as specific as market quote or like a bankable quote that a provider would put in front of a buyer. It's the way I think about it is like, if you want to go on a vacation and you find an Airbnb listing, will you go to Airbnb's website to book it, or will you contact the building owner directly? There's a lot of benefits to doing either, but I mean, I think for us, like the ultimate goal is getting the project done. And so we're not concerned about that use case. We don't really support it as a first-class use case, but it could certainly happen today. The data is freely available.
And then I kind of want to expand that question to Mark and Billy and Gabby. So you've each sort of talked about certain use cases, but what do you feel is the most valuable use of the tool or tools that you've presented today? Is it owners and operators? Is it designers? Maybe you could just comment a little bit, or maybe you have knowledge about who is actively using that. And I think that would be interesting to discuss. Maybe Mark, if you want to start.
Yeah, I mentioned in the presentation the meter, the market, and the management. So depending on the tool that you're talking about, we do have a lot of portfolio managers. That's the core user of Measurable. And then who we call site managers, property managers would be the ones leveraging a subset of the tooling. And then when we talk about the market, we do have ratings agencies and what we generally call capital markets accessing the data. So it does cover each segment of the real estate industry, really, or at least those three segments.
Okay, but do you have a sense about where you're getting the most traction, or what?
Oh, it's with portfolio managers.
It is portfolio managers. Okay. And in terms of scale, larger, are we talking about the CBRE scale, or,
It runs the gamut. I mean, I think we have some customers that have under 10 properties and some that have over 1,000.
Okay.
So it's all scales of property managers.
Okay. Thank you. And Gabby, with Climate Trace, there are so many potential uses. Do you have a sense about, who's using this and how?
Yes, there are a lot of like possibilities like for and use cases. We have been calling it like this, like theories of change, like internally. And on the macro scale, like when you're looking on the entire like Climate Trace data, we can see that policymakers are the ones that are like driving, like using more like our country level and more like aggregated data. When going on like more granular data, we have been getting a lot of like interested in like scope 3 users. And one of the use cases that I presented here today would be like from like designers or constructors that are picking materials. Yeah, I think I'm getting a little bit of like internet problems, so because you guys keep like freezing for me, so I apologize about that.
Okay, and we've seen a few glitches, but right now it's working okay, so thank you. And we'll let you know if we do see any serious problem, but for now it seems fine. And Billy, could you also give us sort of feedback about, you know, who's using Tally? We know it's a lot of engineers and architects, but for that tool and things that are related, what do you think is your, you know, your
I think
core
there,
argument?
I think there's two things. I mean, certainly, you know, this tool, Tally, is a tool like other life cycle assessment tools that is meant to be integrated into the design decision making process, and really is targeted at evaluating materials and comparing one material to the other from an embodied environmental impact perspective, and certainly from an embodied carbon perspective. And so you see a lot of emphasis in shifting decision making to upfront carbon and embodied carbon. And especially when you put that in the context of people using the tool for both new construction as well as building reuse, you begin to engage in an entirely other type of conversation. So we have users, you know, doing a whole range of different types of assessments, but largely these are folks that are making building scale decisions about which materials to use and when, whether it's new construction or reuse. I don't know if that makes sense, David. But
It
I think
does.
what's really super interesting about first listening to all your presentations, which were amazing, and looking at the way these presentations represent a much larger group of stakeholders who are tackling decarbonization, and at various scales, we begin to see how decision making cascades across these different scales. And a larger question we're left with is how do they shake hands with each other? What this represents is a larger building life cycle from, you know, materials extraction or materials processing to actual operations and maintenance. And it does bring up that question of when do you expend carbon, especially from an embodied perspective, and why. So a lot of it's clear we're all asking this similar questions and trying to get at various facets of this from different perspectives and different scales.
And I think a good follow-up probably to Billy is this question of related to embodied energy. The participant says, you know, building reuse is kind of an easy, obvious thing to do, but when we're talking about retrofits, for example, window upgrades or batteries, on-site batteries, or insulation or what have you, what is the best way to inform those decisions? Because we have to also consider, you know, the impact of the grid, and some grids are cleaner and some are dirtier. So it becomes a
Yeah, this is
pretty involved question.
it is also the time value of carbon conundrum. So we can look at assessments, and this is why I was a little or not as direct in my answer previously, but we have done assessments, and we can look at assessments for projects where, and we see this happening, you know, with let's say projects undergoing deep retrofit in order to meet policies, you know, city level and regional level policies, but we can make decisions now between things like, say, double pane glass versus triple pane glass, and from a upfront carbon perspective, the embodied energy expenditure makes no sense from a time value of carbon target perspective. Whereas from a performance perspective, you might be seeing lots of savings. And so depending on where you are and how you're looking at these questions, the answer about whether or not you actually go to sort of really higher performance materials makes a difference. It's a tricky question to answer.
It is. It certainly is. You know, I saw a question that I want to come back to with Gabby. I sort of missed this earlier, and this is a total change of direction, but somebody is asking, could satellite data be used to track livestock emissions? You know, I mean, you know, we're focused on buildings today, but this is a quick side question about things like the meat industry or plant-based meat. Is that anything that's Is that relevant at all to the tools that you provide for data?
I could be like literally talking about this for 30 minutes if I could, but I'm gonna try to like summarize it. Short answer ish, yes. We can we have been able like to detect feedlots facilities, and then based on like the feedlots facilities estimating their greenhouse gas emissions. We did look through direct measurements of methane and signals like from methane, like from satellite data, trying to like see if we could see methane like plumes coming out of like those facilities. Since like the overhead like satellite imageries, like they sometimes passes once a month, and that can be that plume of methane coming out of the facility. It's a one-time thing. It can be a one-time thing, and it's not like continuous because it depends a lot of like the livestock that is present there. It's hard to detect, so it's hard to do like direct measurements of like the gas methane like coming out of like those facilities. But something that we have started doing is detecting using machine learning and AI to detect those facilities, and then using other proxies to estimate the population, the living populations within those like facilities, and then calculating the greenhouse gas emissions.
And is that information visible in the tool at this point, or is it?
Yeah.
It is? Okay.
Yeah, it is. I try to focus like just on the like manufacturing side, but if you go to climatetrace.org, within the like the agriculture sector, you're gonna be able to see a couple of like feedlots that we have released data for the manure management sector and also enteric fermentation.
Oh, that is fascinating. Thank you. I see
David,
that oh, yes,
sorry, I was just wondering if I could ask Gabby a question.
of course.
Is that possible? Thank you. Thank you. So, Gabby, I'm really curious about your perspective on how the, let's say, factory level or manufacturing level data shakes hands with the kind of data that a tool like EC3 or Tally ingests via EPD or an environmental product declaration. Because as I mentioned, and I tried to demonstrate that EPDs actually are site specific. However, EPDs can represent many products at once or one product exclusively.
I'm glad that you asked that question, because when you were like mentioning about the EPDs, I was like, wow, like there are like some ways that maybe like we could like work on that together. So our data, the data that we produce, it is some sort of like it is independent. So we can, and since like we have like our ownership data as well, like for specific like assets, what we are calling assets like at the facilities, we can aggregate that data and get it like a company wide within like all the different like sectors that Climate Trace tracks to get the total emissions estimates. And then like one possible like exercise that we could do is compare like the company wide disclosure, emissions disclosure, if they are like matching or not. But our data right now, it's the scope 1. So it's down to the manufacturing. And then we can like aggregate it up like to the other like various like company wides. So yeah, in different like and we are walking through like it is on our roadmap to incorporating scope 2 and scope 3 other like analysis as well to our products. But our first step right now, it's like focusing on scope 1 of emissions.
Thank you. Thanks, David.
No, thank you for your question. So we are getting towards the end of our time. So I wanted to have kind of a wrap-up question to pose to you all. And the question is really if you would just reflect on sort of future directions for your company, for your product, and also, you know, the kind of funding and investment that is available now. I think this is a growth area, and I would just like to hear from you all about, you know, where you plan to be focusing, and do you see, you know, growth and ongoing support for your work and these tools. And Billie, maybe we'll just start with you and go through the order that we had for your presentations.
Yeah, I mean, I tried to hint at some of the growth areas when I was presenting. Certainly, right now, in the chart that I showed around data, just simply data availability on building products, what we were seeing is just tremendous availability of EPDs, but that's coming with a lot of transparency, but it may be coming with transparency at cost, meaning that we have incredible uptake in the use of EPDs, and there's just a larger question about whether or not we really know how to use them. They're not all created equal, and so there's this growing, as always, with new types of data and new practices, there's a growing concern around literacy and standardization, and so that I know that that is going to be tackled at a very, very high level nationally. Then there's this question of what else we need to tackle. And so as we try to demonstrate, there is an intersection between decarbonization and more generally climate action and climate justice. And as we look at these issues, we have to ask what other impacts are associated with materials more directly. And I was really glad to see, Gabby, in your presentation, you're talking about place-based impacts very, very directly, and that connects us more deeply into communities and other types of issues associated with manufacturing. So that is definitely a modeling practice that has emerged, and there are a number of people that are attempting to really grow a practice that's associated with what's called GIS LCA, alongside BIM LCA, alongside social LCA. So a lot of these modeling practices are emerging, which means that there's a lot of data that's data sets that are potentially non-existent that are presently growing, which means there's a lot of concern for quality. I hope I answered your question, David.
You did.
Awesome.
Yes. No, the GSL, did you say
GIS LCA.
GIS LCA, interesting,
Yeah.
a new direction.
Yeah.
Well, maybe that sounds like a perfect handoff to Gabby to offer any closing thoughts you have.
It is kind of, yeah, it's kind of good timing because we started talking about like our future like roadmap and like doing like the planning. So for Climate Trace, we have released like for this year, we have released on the manufacturing sector all major like manufacturing factories globally, which is more than like 20K. I don't remember the metrics really well. But for power plants, for instance, we have like just released like top 500, nearly like top 500 worldwide. So something that we want to expand, like working towards, it's doing more like power plants, like emissions estimates for all power plants globally. That's like, no, it will be like a lot of like, that is going to keep us like busy. I gave like a quick like sneak like preview. We're going to start like working, not just like moving towards like our scope 2 and scope 3 of emissions estimates as well. So now that we have like scope 1 of emissions estimates that can allow us all those analysis as well. And also like in our buildings estimates, like for on-site heating, on-site like fuel usage of commercial and residentials, as I sneaked on the presentation, we are working on our incorporating more of our like modeling for that as well for other regions in the world that doesn't have like very much like good data for those like emissions estimates coming on the on-site heating.
All right, thank you. Yes, I guess with the global nature of your work, you have unending, endless opportunities for growth, I assume.
Yeah, and it's always like we're always keep like thinking about getting better like results, like improving accuracy for sure.
Right, of course. Thank you. And Manos, you had a slide where you sort of noted 3 items that you've kind of checked off and a couple of growth areas. But if you want to maybe just expand on those, remind us again what those were, and also just how you see the uptake of these tools. I mean, it seemed like you had an impressive track record already.
Yeah, I mean, I think as I hinted, as you said, I mean, where is this thing going? Like culturally, and like, you know, society wants it. It's economically feasible. We need to do it. We need to decarbonize. The value proposition is there. To me, it's a question of, into station A, it's a question of getting the information out and making this really a no-brainer. And so the focus of the company is really data openness, get this information out, make it relevant to people outside this panel, right? And outside this group of highly specialized scientists, and really get it out to the decision makers and to folks that actually, you know, make these decarbonization decisions and sign the bottom line. And so our focus is, you know, expanding our coverage in terms of buildings and in terms of solutions, getting our information out, improving user education, and really digitizing more and more of this process. And so making it like really, really easy. I also want to say what's really interesting about this panel is like each one of us comes from the structure of our companies is very different. Climate Trace is a nonprofit. Kieran Timberlake is a privately held company. Measurable is a Series C startup. We are a seed stage startup. We are like a very, very, very early stage company. And so I think that for the audience as well, it's kind of interesting, right? Like this is a problem that we attack from all these sorts of different angles. And there are all these sorts of different approaches. Like we take a tech and data first approach to the problem. But of course, you know, we need everything. It's an all of the above kind of situation.
Well, I think that's a good lead into Mark then. You mentioned some of the things that you're working towards, but maybe you could embellish a little bit and let us know, you know, also about how you feel about your prospects going forward.
Yeah, absolutely. So going forward, to put it succinctly, we see carbon data like this being involved in every real estate transaction. It's just going to be part of doing business. So that's sort of the grand future, and that can mean everything from acquiring a property to refinancing it to getting insurance. Just every transaction is going to be informed by this. That's where we see the industry going. That's our bet. As far as is there investment in this and is there interest, you asked about where we're getting traction, and I sort of misspoke. Most of our customers are portfolio managers, but for the data product, which is relatively young, the traction is with other types of entities, accounting and consulting companies, ratings agencies, stock exchanges, major banks. So there's a lot of what you might call heavy hitters with a lot of money that are interested in the data. And that's sort of validating our vision that this is going to be part of doing business in real estate.
That's such a positive closing note. And from my own experience, I've been in contact with people who are sort of, you know, one day they were the chief engineer for a REIT or something, and now they're like the chief carbon officer. They've all, you know, elevated the concept of emissions and carbons has just been elevated to this highest level, which is a positive thing. Yeah. Well, I want to thank you all for your presentations. They're all fascinating. And just a note to the audience, this recording will be shared. And we'd like to just remind you all to fill in the survey. There's a link in the chat box there. And please, you know, let us know about things that you'd like CBE/PG&E to include in future events. So with that, we'll close. And thank you all again for your talks today. And thanks to the audience as well for your questions and for your attention. And have a good day.
Thank you.
Thank you.
Thank you.
Thank you, everyone.